everyone, this is Snake here, and in today's video we are going to look at the practical sides of logical gates. By that I mean we are going to be working with the chips basically. I'm going to give a demonstration on all the truth table that I have shown you in the previous video. So without further ado, let's get started. So guys, before getting started I want to talk something about safety, okay? Now currently this is working with a Arduino Nano, and that is providing a 5-volt supply, so there is very little chance for you to get shocked. But one thing I want you to remember, that you see, if I keep the circuit connected and change the inputs, that has the probability of frying the chip basically. You see that every electronical components has a surge current basically. It is most prominent in case of motors, but every component has that. So if the circuit is kept on and connected completely, and I switch the inputs, say from 0 to 1, 1 to 0, like that, there is a chance that the surge current might reach a point where it may burn the circuit, and the shelf life of the chip may be gone as well. It will be damaged basically. So in order to have a long lasting chip, always disconnect the circuit before making the changes. Disconnect the circuit, make changes, reconnect the circuits. Got that? Cool. So guys, now we are going to look at the NOT chip, okay? The 7404 chip. So remember the truth table of the NOT gate, okay? If the input is 0, then the output will be 1, and if the input is 1, then the output will be 0. Okay guys? So first let's see the chip actually. You see how I position the chip here? The notch here, I have put it in the left side direction, so the bottom pin of it is the first pin. And since the NOT gate is a one input gate, the first pin here is the input gate and the second pin here is the output gate. That is why you see I have connected the resistor here, that is in turn connected to the LED that goes to the ground basically. And now here you go in this direction in the numbering of the pin. So this is the 7th pin, and that is the ground pin, and that is connected to the ground line. And going in this direction, this top one is the 14th pin, and that is connected to the VCC, the 5-volt power supply basically. Okay, now with the introduction part of it done, let's connect the circuit. Okay guys, I see the input is connected properly, so let's power it up. You see the LED current, the LED has current flowing through it, and it is glowing right now. Because remember the truth table, when the input is connected to the ground or it is 0 basically, the output will be 1. See, the current is flowing. Let's connect this multimeter first to the ground, okay, and test the output basically. You see it has a reading of 3.79 volts, which is basically considered logic high. Okay, it is 1. And if you see the VCC input as well, it is 4.59, so nearly about 5 volts basically. So there is a significant potential drop here, you see, but that's beside the point. You see it in action, right? The voltage is working, the voltage is flowing perfectly, and the LED is glowing for input 0. Okay, now let's disconnect the circuit and see it for input 1. Okay, so I'm going to connect it to the 5 volts. Okay, and now I powered it up, and see the LED this time did not turn on, because for input 1 the output will be 0. So again, let's see the voltage. Okay, for the input I see 5.4, around 4.45. So the output here in this case, in the second pin, is 0. See, now this is the NOT gate in action. Okay guys, so guys, next up we are going to look at the OR gate. Okay, 7432 chip. Again, look at the truth table, remember it. Okay, when it is 0, when both inputs are 0, the output will be 0. Okay, when one of the inputs is 1, the output will be 1, and when both inputs are 1, then the output will be 1 as well. So let's get down to it. So here I have the 7432 chip, okay. It is pretty much the same configuration. Just note that unlike the NOT gate one, there are two inputs. So pin 1 and pin 2 are now the input pins, and pin 3 is the output pin, okay. And now that is connected to the register, that in turn gets connected to the LED, okay. So let's first make the connection before starting it. So the red one goes to the second pin and the first yellow goes to the first pin, okay. Now this is 0 0, okay, when the both inputs are 0. So now I am going to turn this on. See, the LED did not turn on because remember the truth table, when both inputs are 0, the output will be 0, okay. Now let's change the configuration, okay. First, remember safety, okay, turn off the circuit first. So I turn one of the inputs to be 1, okay. Now let's see what happens. See, the LED got turned on because if one of the inputs is 1, then the output will be 1 as well, okay. Now let's flip the inputs and see it, though the LED will still be on as well. So I make this one 0 and I connect the other input to the 1. The result will be basically the same, but hey, let's see it, okay. See, the LED is on again. Okay, now for the final piece, when both inputs are 1, okay. So check thoroughly if the connections are right or not, okay. I think it's a bit loose. Okay, no. So let's turn it on, okay. The LED is on. So see, this is the OR gate in action, okay, where the first two pin 1 and pin 2 are the input pin and the output pin is the third pin, and it goes on continuously. The thing to get is that I'm showing you this like this here with only the first section on, but there are 4 OR gates in this around each pin basically. To understand it, just type in the chip number, say 7432, and see its data sheet basically, or its pin diagram basically, and you will get it. There is no need to explain it here in the video. You can just get it on the internet, on Google or Bing or whatever you use, okay. So guys, now for the final gate, okay. This is the 7408, the AND gate basically. So now as per the truth table, let me show you here on the screen right now. Yeah, you see here, when both inputs are 0, the output will be 0. If either of the inputs is 1 and the other 0, then also the output will be zeros. Only in the scenario when both inputs are 1 will the output be 1 basically, and we are going to see this right now. So I've made the connection here right now. Both the input, the first pin and the second pin are connected to the ground, so this will be the input 0, both input 0 case, okay. So let's connect it and see. See, when both inputs are 0, the LED did not turn on, so there is no output to it, okay. Now let's check the scenario when one of the input is 1 and the other is 0, okay. So I shift the yellow one to VCC 5 volts and let's turn it on. See, it still did not turn on. Remember, I'll show you the truth table again. See, if one of the inputs is still 0, the output would still be 0. That is why the LED did not turn on, okay. Again, the reverse scenario, yellow on the ground, red on the VCC, okay. So yep, again same result. If one of the input is still 0, the output will be 0 always, okay. Now let's look at the final step, okay, when both inputs are 1, okay. Disconnect, change connections. Remember the safety rules, guys, okay. Always disconnect before making changes, then finally reconnect, okay. When both inputs are 1, see here, when both inputs are 1, the LED finally lit up. So this is the AND gate in action. I hope you like it, guys. So guys, that was the practical aspect of logical gates. Okay, I hope you like this video, and if you have any queries, please put them down in the comment section, and please like and share my videos and subscribe to my channel. Okay, and one final thing to say, guys: to learn, never memorize. Bye bye.